What we're going to do in this video is we are going to talk about ratio tables. And you can find this information in your book on pages 240 and 241. Okay, you can find that information on pages 240 and 241. So why don't you pause the video, open up your book, and get ready to follow along. Okay, in the book, they begin by talking about ratio tables and using them to help you solve a problem. So how can you use ratio tables to solve a proportion? Now remember that a proportion, of course, is an equivalent amount to some ratio. Like we could have a 3:4 ratio, and we could create a proportion through multiplication or division if the terms weren't Low's term already, by simply doing multiplication. And we would create our proportion, which is the equivalent to our initial startup ratio. Okay, so that's what a proportion is, and we often use the word proportional as we are going over it. But anyways, here's our situation. For every 7 cans of tennis balls sold at the sports store, 3 tennis rackets are sold. So here is our situation that tells us what our initial ratio is. At this rate, and this is the rate, 7 cans to 3 tennis rackets, how many cans of tennis balls would be sold if 15 rackets were sold? So what they want to know is how many cans of tennis balls are going to be sold if you sell 15 tennis rackets. So in other words, they want to predict how many tennis balls they're going to need if they sell that many rackets. So the first thing that you want to do to understand this problem and this proportion is to look for your initial ratio of 7 to 3. So we have 7 to 3 as our initial ratio. Make sure you identify the units you are working with. So we have cans and we have rackets, okay? And then they're telling us the guiding term from our proportion. So our proportional ratio, which is 15 tennis rackets. So we know that we're going to have 15 tennis rackets. What we don't know is how many cans of tennis balls we're going to have. Okay? So mathematically, we know that if you simply multiply by 5, you get 15. And we do that to both terms, and it'll tell us that we need 35 cans of tennis balls. Okay? But we want to take a look at that using tables. Okay? So what they do is they say, write a proportion and use X for the number of cans of tennis balls that would be sold if 15 rackets were sold. So then they give you the actual proportion with X as the unknown, okay? And then what we want to do is we want to make a table, okay? So we create what is known as a ratio table to solve the proportion. And we will find ratios that are equivalent to our startup ratio of 7 to 3, okay? So if you look, we have our table, and here is our startup, or the beginning ratio of 7 to 3, and we want to multiply both terms of the ratio by 2, 3, 4, and so on until you find 15 tennis rackets sold. So in other words, we've created this table, and we have this wonderful table that they've created, and you've got your cans of tennis balls, and you've got your rackets. Okay? And we take our starting ratio, which is 7 to 3, and we want to reach a final ratio of something to 15. Okay? So what we're going to do is we're simply going to multiply each of the terms. We're going to multiply each of the terms to get an amount that is equivalent until we reach 15. Once we do that, once we reach 15 here, we know we will reach our equivalent amount up there. So this is the 1 column, so 1 times 7 is 7. 1 times 3 is 3. This is the 2 column, so we know that 2 times 7 from our initial ratio is 14. We know that 2 times 3 is 6. So what we've done is we've created an equivalent ratio. All right, and we're going to do that in each one of our columns. Okay, so let's take a look at that, okay, and see how it works out. So our first column we multiply by 1. Our second column we multiply by 2. 2 times 7 is 14. 2 times 3 is 6. Our third column, see if it gives us 15, would be 3. 3 times 7 is 21. 3 times 3 is 9. So we're not there yet. We then go on to a fourth column, and we have 4. 4 times 7 is 28. 4 times 3 is 12. So we have our equivalent, but it's still not 15 yet. So we want 15. Well, we have a column here. We have our fifth column. And so if we know that we want to reach 15, we can then say 5 times 7 is 35. 5 times 3 is 15. So we did indeed create an equivalent ratio like that. Okay? So we've created our ratio, which tells us that it's a 35 to 15 ratio. In other words, we need 35 cans of tennis balls, okay, in order to solve that. And that is how you create equivalent ratios using tables. Okay? Here's an example of a problem that you might want to give a try, and it is in your book. It's problem number 1. Why don't you pause the video and see if you can solve that problem. All right, well, let's take a look at this problem and see how we did. To make plaster, Kevin mixes 3 cups of water with 4 pounds of plaster powder. Okay, this gives us our initial ratio of 3 cups to 4 pounds. Okay, that's our initial ratio. Complete this ratio table, and then you will find out how much water he will mix with 20 pounds of powder. Okay? So again, our target is to figure out what the ratio is if we want 20 pounds of powder. Okay? So that's our target. All right? And then what we do is we say, okay, we're going to multiply by 1. And we get, from our initial ratio, we're making an equivalent ratio. So our initial ratio, 1 times 1, of course, gives us the same terms. Then we're going to multiply 2, and we will do 2 times each of our terms. Okay, so we would do 2 times 3, and we'd get 6. So we should have 6 there. And of course that works because if we multiply 2 times the 4, we will get, it's more like a 9, 8, and that's what we have. And then we continue to fill in our table, and we multiply by 3, and we see that 3 times 3 is 9, and then we see that we are in our fourth column, and we would now take our initial ratio of 3 to 4 and multiply by 4, and we would get 12 to 16, and that would be in our table as well. And then our goal, of course, is 20, so now we're in the fifth column, so we're going to take our initial ratio, multiply by 5, and we would get 15 to 20. And that tells us that we would need a total of, we would need 15 cups of water, 15 cups of water if we had 20 pounds of powder. Okay? So hopefully this video gave you an idea how we use ratio tables. If you have any more questions, I've linked some other videos in Schoology to help you out. And you can always use your book, your parents, and see me during homeroom for help.